In the last chapter, we talked about fractions, and at that time we said that fractions were used to describe parts of wholes. Well, in this chapter, we're going to talk about decimals, and we'll find out that decimals are also used to describe parts of wholes. And in fact, decimals are sometimes referred to as decimal fractions. Well, you remember with fractions, the composition of fractions was that we have a whole number numerator, a whole number denominator, and those two are separated with a fraction bar. Well, to write decimal numbers, we use the idea of digit value that comes from our study of whole numbers. In fact, in decimal numbers, there is a whole number part and a sort of the fractional part. Here's what I'm talking about. I've described here, I have blanks here for digits, and here's a decimal point. And we're going to have digits that lie to the right of the decimal point and digits that lie to the left. Now, the digits that lie to the left are simply describing the whole numbered part of a decimal. And if you recall, the digits have value when we're talking about whole numbers, and these are the digit values that would lie to the left of a decimal number. So if we have a whole number over here, the number that is in this position is the thousands digit, and here we have the hundreds digit, the tens digit, the ones digit. You see, let me write that down. So the digit here is the thousands digit, and the digit here is the hundreds digit, and then the tens digit and the ones digit. And here's what I want you to notice, that if we take this 1,000 and divide by 10, we would get 100. So this digit, you see, the digit value here is 1/10 of the digit value there. And if we take this one, divide by 10, divide 100 by 10, we get 10. So dividing by 10, this is 1/10 of that rascal. And then 1/10 of 10, oh, that's 1. You see, divide 10 by 10 and we get 1. That's the idea. So for each one, the digit value can be thought of as coming from taking the value that we have, divide by 10, and put that value in the next slot. Now, I want to mention that because we can use that technique to describe digit value to the right of the decimal point. You see, if we take the value of this digit, its value is just 1, but then divide by 10. 1 divided by 10, oh, that's 1/10. So the digit value here is 1/10, and this is called the tenths digit. Divide 1/10 by 10, and it's 1/100th. And this is called the hundredths digit. And then divide by 10 again, and so on. And it just keeps on going forever. But divide this by 10, we get 1,000th as the digit value, and this is called the thousandths digit. Now, notice the THS here for each one of these. So it's tenths, hundredths, thousandths, and then we would continue on. It would be 10,000ths, 100,000ths, millionths, 10 millionths, and so on. All right, so that's the idea. Now let's talk about reading decimals. When we read numbers that have a decimal in them, there is typically a whole number part and let's say a part of one part. You see, a fractional part. So whole number part, fractional part. And we read the decimal using the word and. So this is 47 and... Now, for the fractional part, we read the number that is to the right of the decimal, and we describe it according to the value for the rightmost digit. So this is 47 and 3/10, because the 3 is in the tenths position. This is 47 and 25 hundredths, because the 5 is in the hundredths position. You see, the digit value for the 5 is hundredths, so 25 hundredths. This is 47 and 25, but this time the 5 is in the thousandths position, so we say it's 25 thousandths. So 47 and 25 thousandths. This is, now notice we have a 0 in the whole numbered part. So we don't need to read a whole number in here, and we don't use the word and. We just read the fractional part over here. We say this is 83, and the 3 is in the hundredths place, so it's 83 hundredths. And this is just 5, and the 5 is in the hundredths position, so we say it's 5 hundredths. Now, we'll get into the conversion of mixed numbers and into a decimal form and decimals into mixed numbers and all of that in a little bit. But some of those situations are relatively easy. For example, if we're thinking about 5 and 3/10, that's the way we'd read this as a mixed number, 5 and 3/10. Well, gee, we have if we think about the way that we were reading decimals before, we can just convert this right into a decimal real quick because it's 5 and, you see, and then 3 in the tenths place. And that's all there is to it. And anytime we have a denominator here in this mixed number, anytime the fractional part has a denominator of 10 or 100 or 1,000, it's pretty easy for us to convert into a decimal form. This is 7 and 18/100ths. So 7 and, you see, 18/100ths. Well, let's see, 18, and we want to write the 8 in 18 in the hundredths position. So we have 7 and 18/100ths like this. 14 and 32 thousandths. 14 and 32 thousandths. Well, we want the 2 in 32 to be in the thousandths place. Now we need to think about that a little bit, and it might help us to write placeholders here. And this is the tenths, hundredths, thousandths position. So we want the 2 in 32 to appear right here. So the 2 goes here, the 3 goes here, and we need something to hold this position. And that something is just a 0. So 14 and 32 thousandths. 8/100ths. Gee, no whole numbered part. When there's no whole numbered part, we kind of emphasize that with a 0 to the left of the decimal. So 8/100ths. The 8 is in the hundredths position. Let's see, tenths, hundredths. Oh, the 8 would be here, and we need a placeholder. So that's the idea. Now, we're talking about mixed numbers here and mixed numbers over here as decimals. So a nice conversion here between the two. And as I say, we'll get back to this idea in a little bit later in this chapter. Let's talk now about taking a decimal number written in words and writing it in kind of a numerical form, that is using digits. And we can kind of be intuitive with this. And when these words, or when the description of the number is written correctly, we just identify the and in the description as the position for the decimal point. And that's the first thing we want to look for. 3 and, well, the and is the position for our decimal point. So 3 is the whole numbered part, and the word description to the left of the word and would be the whole numbered part, you see. And the word description on the right of the and would be the fractional part, the part that appears to the right of the decimal point. So this is 3 and, you see, 8/10ths. 8 in the tenths position. 7 and, stop right there, 7 and, all right, now let's read on. 65/100ths. All right, 65. The 5 in 65 needs to appear in the hundredths position. We have tenths, we have hundredths. The 5 in 65 goes here, so here's the number. 7 and 65/100ths. 605 and, stop right there. 605, that's the whole numbered part, so we want to write the number 605. Now remember, in writing whole numbers, we went through a discussion of this before. 6 is in the hundreds position, you see, so it's 605, you see, 6 in the hundreds position, and then a 5 ones, so we have 605 and, decimal, 402 10,000ths. Whoa, let's identify the 10,000ths position. Let's see, we've got tenths, hundredths, thousandths, 10,000ths. All right, there's the 10,000ths position. 402 10,000ths. So the 2 in 402 goes in that position. So here's where the 2 goes. 402, oh, this is 402 10,000ths. But we need a placeholder for that digit. So this is 605 and 402 10 thousandths because the 2 is in the 10 thousandths place. It's wise when you write these to reread it and see if you're reading the little phrase that you started with to just verify the number that you've written. Now remember rounding for whole numbers. When we rounded whole numbers, we were just rewriting a whole number to the nearest certain digit value. Now we do a very similar thing when it comes to decimals. And we use exactly the same technique. That is, we look at the digit just to the right of the one that we're rounding to. Here's what I mean. Suppose we want to round 432 to the nearest hundred. Now, we're just reviewing here with this one, and we'll get to decimals in just a minute. Round 432 to the nearest hundred. Remember, to do that, we say, all right, here's the hundreds digit, and we look at the digit to the right. And if that digit is less than 5, and it is here, then we drop that digit and we actually replace it with 0. And we leave this digit alone. This is 400 to the nearest hundred. You see, we replace these digits with zeros. Now, if we were rounding up, if this were 473, then we would make the 4 a 5 and make these zeros. Remember that? Go like this. Sure. All right. Here we want to round 4 and all of these digits. I'm not going to read the entire number here. It's, let's see, tenths, hundredths, thousandths, 10 thousandths, 100 thousandths. So it's 63,946 hundred thousandths, you see, as the decimal part of this. All right, so we want to round this to the nearest tenth. So we identify the tenths place, and we look at the digit just to the right. It happens to be less than 5. So we're going to take it out. Now remember, when we rounded up here, we made these digits zeros. And you might think, well, gee, let's just make all of these zeros. Well, we don't really need to do that with decimals, because we needed those zeros here to describe a number that is in the hundreds when we're rounding off to the nearest hundred. But here, when we're describing the nearest tenth, we only need to describe a number that goes to the tenths place, you see. So to the nearest tenth, this is going to be, the decimal part is going to be 6 tenths. So it's 4 and 6 tenths to the nearest tenth. Suppose we want to round the same number to the nearest hundredth, to the nearest hundredth. Let me erase here. You might think about this as I'm erasing. To the nearest hundredth. Now, let's see, the hundredth position is this position. We look at the neighbor to the right. It is a digit which is 5 or bigger. It's 9, you see. And therefore, we need to make that one larger. We make this one larger, and we just lop these off. Just lop them off. You see, make that one bigger and lop those off. We have 4.64. 4 and 64 hundredths. To the nearest 10,000th. Whoa, 10 thousandths. All right, let's be careful now in identifying the position of the 10 thousandths digit. Tenths, hundredths, thousandths, 10 thousandths. To the nearest 10 thousandths, we look at the digit to the right. It's 5 or bigger, and so we're going to make that one larger. So we're going to bring down the 4, bring down the decimal, bring down the 6, the 3, the 9, and make that one bigger. You see, that's the idea. So it's 4 decimal 6 3 9, and what we're changing is this 4 into a 5, and we're dropping that off. So we have this. So it's 4 and 6,395 10 thousandths to the nearest 10 thousandth.